Yo, 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 yo. What is up, everyone? Hope everyone had a nice weekend. I keep working on the wings today. I want to see if I can get the core wing section pretty much mostly done. I was playing around with some stuff yesterday before I went to bed. For instance, putting the servos in, just laying them in there, see how big they are compared to the wing. And like, these ain't no small servos. These are decent sized servos, right? Yeah, let's go face cam. Let's go face cam. These servos, they're pretty big, right? They're not the biggest you can get. Like, I've seen servos that are like this, right? But I think these are too small. I'll put them in there and I'm like, well, I'm gonna have to work out like just the right position so I get the full throw on the servo arm and everything. And I put them in there and they look small on the wing, which, because they are. The wing's 310 mils from chord tip to chord tip. You know, it's a big wing. So, yeah, that happened. Look at it. It's just like, right. Where do you want it? Little to the left, little to the right. Alright, let's get this black out of the way, because it's bad for the streaming. Colors. Gradient. Apply. And before we save this, switch back to technical. Save. No. I do not want to save it as a level of 1 detail. Let's unsuppress this and just actually remove it from... Just remove it from it. No. Cancel. Representations. Return to master. There we go. There we go. Sweet. I need to actually set that up properly so that I can switch between different design representations using the wing forms and stuff in the assembly. But yeah, so this one was done. I made some changes to it. Again, I'm going to have to go back to wireframe. I reduced the number of the ribs. I lowered the rib count and I knocked about, what was it? Where's the picture? Let's go back to save pictures. So if we look at the original screenshot I took when I first finished making them, which is 254 grams versus 249. I took out 5 grams. Every ounce counts. That's what Mike Beatty says the whole way through his build series and his new build series. Every ounce counts. They're always trying to remove weight. So that's the same ethos we shall apply here. We shall apply here. No, why did I do that? Go to technical illustration. We go to save. Yes to all. Doop 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 doop. Right, we can close that one down. Update this one. Lovely. I also added in the carbon fiber spar on this one, and then added an end section view, a half section view on the skin of one of these servos when I laid them in there, so I could see where they were going to sit in relation to the hinge for the flaps. So I'm still umming and ahhing about how I'm actually going to actuate the flaps through the back here, because in the aircraft there's a little slot here where the linkage comes through, and then the hinge point sits lower. So if I move it like so, right, okay. Zoom in here. So the linkage comes out the wing here like this, and then the hinge point for the flap comes off here, so it actuates off like that, rather than what you normally do with model aircraft and whatnot is you have your hinge point here, and then you have your servo arm sticking out down here, and the linkage that comes out to another control horn that sticks out. So now you got stuff sticking out in the airstream, which is no bueno. No bueno. No good. So, yeah. This is a much better way of doing it. I really like that sort of comes through. But the thing I'm trying to work out is how I'm going to link it up on the inside. Am I going to use just a single servo arm that drives it directly through a linkage through the wing? Or do I want to get clever and turn the servo 90 degrees and use the rotation, the throw rotation of the servo to run a worm screw and do, you know, a worm drive on it? Or do I want to move it further away, turn it 90 degrees, and then have a 3-point actuator so that we have, you know, redundancy? And then it's actually distributing the weight of the linkages across 3 points on the whole airframe, rather than all in one spot. But before I even get into any of that, I have to first decide how I'm going to cut the wing up. Because at the moment, it's not, I haven't even decided that. So if we look at the leading edge slat was easy, because I had the end caps, and then you have a section, and then another section. So it breaks up into 1, 2, 3, 4 main sections, and the 2 end caps. 6 parts in total. The main wing I'm going to have to break up into about 5 sections, which means we're going to have a split down the middle somewhere, and then a split either side. Now I don't want to split on these control horns, on these hinges for the flaps and ailerons. But at the same time, I don't want to split wherever I'll have an access hatch for the servos and stuff. So it's a bit of a catch-22. Work out where to place the servos so that I can design the access hatches, so that I can determine how I'm going to slice it up for printing. But at the same time, I can't determine where I'm going to put those things if I don't know where I'm going to slice it. Hey, you see, you go back and forth. So, I need to think about it some more. But first, I do need to put in some more ribs. There's just not enough. Just the 5 that are in here is not enough. We got 1, 2, 3, 4, 5. Wahaha. So, let's double them up. And we used this, this, and this. But we did it in the middle. Which is, Rectangular origin, direction X. Switch to my favorite view, wireframe with hidden edges. Actually, we're going to go full wireframe because hidden edges hides features, new features and stuff. So the distance I placed on these was half the distance from the center thing here, because this isn't the exact center of the aircraft. This isn't the exact middle. So I know I'll be able to put a split in here and run the servo on this side over here, because this is the middle hinge for the flap, and this is the aileron. No, I'm looking at it backwards, that way. Aileron, flap. It was the right ones, but I was just looking at the wrong side. I was pointing out the front of the aircraft. But yeah. So I want this to come about halfway between here and here. So let's first measure that point. Here to here is 264.5. Let's do this the lazy way. Between here and here, measure that to that. 131.750. Okay, so that's a weird number. Why don't I just have a look at this? We did that at spacing, so let me just grab that. Control C, close it. Rectangular, this, direction, x-axis, spacing of 2, yep, we only just want the 1. Now if I'm smart about this, I won't do it like this. I'll do it like this. This through to this, direction, x-axis, place the spacing in, divide by 2, right, click OK, and then we'll move that down to this one, right, so I want to look at this one now quickly, because that's the other side. I want to grab that number, Control C. And then we want to move it back again to here. I want a rectangular on this, and this. Direction X. Flip it around. Control V. Divide by 2. Right. Now I'll just go full hog on everything again. We open this one up. We include that pattern. Unfortunately, it's going to make one out there, but that's alright. I can suppress that last one. Sweet. And we open up this one, which is the other side, and we include the other one that we made. That one, yep. And then we're going to hit save. We are going to open up that feature again, this last occurrence. Damn. Oh well. It's not letting me do it the way I wanted to, so we have to undo that. There's another way we could do it. If I put a work plane on the center of this one and a work plane on the center of this one, then I can mirror it over. It's another way to do it. But I think again, it will, I'll have to grab that feature by itself. Actually, let's go forward again. Let's bring those back. If I suppress the feature in here, that's the original one. You can't suppress the original point. Yeah, I'm gonna have to do the mirror trick. Back. Hey, what you doing? Midpoint, please. -1. -1. Mirror on the wall. Feature. Should be able to just select. Where am I at? What's going on? That just selects the one in the middle. It won't let me select that. Why? Why be difficult? Why are you being so difficult? Right. Okay then. That's how you're gonna be. Pop you back up there. Just gonna have to do a whole bunch of rectangular features. I should start using the sketch-driven constraint, but I still haven't worked out how it works yet. I need to play with that. Maybe that's what I should do. Nah, I'm lazy. Direction. X-axis. Features. Listen. Spacing. Oh, what was the last one? Spacing? God damn it. Cancel. Open this one. Control C. Rectangular feature. Listen. Direction. X. Spacing. That. Control C. 5x2 plus. No, divide by 2. Divide by 2 times 2? No. I want to put one here, so times 3. Right, let's put some brackets around some shit. Divide by 2 times by 3. Put it sit there. Right. Okay. And then we need to open up this one. Control A, Control C. Rectangular function. This one. Oh, excuse me. Direction X. Flip. Close bracket, paste, close bracket, times 3. Click OK. End of part. Control S. There we go. Got it in some more. Now, it's a little strange that the spacing of these ribs is smaller towards the end of the wing and wider at the root of the wing, where you'd think it would be backwards, because this is now putting more weight on the end of the wing. And that is true. However, we also have the ailerons here, and you get a lot more movement out of the ailerons all the time. So, to me, it would also make sense to... Let's just delete these, we don't need these anymore. So put the extra strength here. But then again, that extra strength has... those forces translate through the wing, so you'd have to put it here. But anyways, that looks like a decent spacing, even if these are a little tighter down this end. Now, the next thing I want to put in here is some kind of longitudinal bracing. I mean, we've got the carbon fiber tube in there, and we'll have another one at the front. So really, it's more than enough. We shouldn't add more weight. We should not add more weight. We should not add more weight. Just keep saying that. Do not add more weight. Do not add more weight. Right. Let's work out how to split this thing up. We have 1, 2, 3, 4 sections. Total length is long. I want to print these laying down in the printer. I don't want to print them standing up. I mean, I can print them standing up, but it's going to make it trickier to print the internal ribs because you've got massive overhangs then. Shouldn't be an issue because you're printing around the outside. And resin printers can usually get away with that kind of overhang, but the overhang I'm worried about is the lips for the carbon spars. These stick out, so it would be fine printing this surface, but this bit that's hanging, it would start printing this ring, and this ring would stay on the print bed. So that's no good. Everything has to be printed in orientation that allows to prevent overhang. Now what I could do is just make very thin streamers that run between these all the way down. But I'd rather not. Or then the other thing I could do is slice it up at every section of rib and have lots of pieces of wing to stick together. I mean, it's doable. All I have to do is wet this ends with a bit of resin and they'll cure together as if they were a single part. The beautiful thing about resin. Think about it some more. Let's put some rivets on this thing. RC, reference material. What kind of rivets do we have on the underside? Not many, if any. One, some there with that one, there with that one. One's in the halfway points. There's this light. There's whatever this is. I think this is a camera. We'll worry about that counterweight to the ailerons when we get to doing the ailerons. I think this is a check check for the fuel tank, the sump point, where you do your hydroscopy test to see if any water's got into the fuel tank. I don't know if we're going to bother making the trim tab because you normally set your trim with servos. It would be cool to have a proper mechanical trim tab and use one of these tiny micro servos that I've got. But then you've got more cables and wires and more channels to deal with. I just almost tried to rotate this image like I do in the Inventor. Shift middle mouse click. Let's see, we got any other photos where I can get some... I know there's that one with the wingsuit guy. That one's a good one for... This one you can actually see what the rivets look like pretty close up. So the ones I had on the leading edge slat are pretty close to those. This shark fin I want to make as a separate piece. I also need to work out where it sits on the wing. Wow, let me just make a... Yeah. Yeah, one of my lights for the camera is flickering. It's a USB plug-in LED thing, and I think it's not getting quite enough amperage plugged into my USB bank. I should get a nice USB charger for it. I don't know. We can safely make rivets all the way down that back edge there, and then there'll be rivets around the edge there at the very end. Let's open up this one. So we know there's rivets from the line of where he added the new part. Oh, I still need to do the little step in here. So when this is going to be part of the aircraft frame, right? This line. But this step here is going to be part of this. So I need to include that step. And then this is for... I think these are for... This is the control conduit and stuff. Or there can't be a fuel pipe. No, fuel pipe runs in the main wing. This is a handle that he uses to lift himself up to fuel the thing at the gas tank here. I like how he's got these vortex shedders here. It's a strange place to put them. I would like to know why they go there. I would have thought you'd put them a little further back near where these rivets are. Or even further back here. Right, so... The wing seems pretty clean. As it stands. There's a line there, and there's a line there. Let's see how big that step is. Where'd that image go? Come back here. I'm not done with you. Wow, okay, so that lines up pretty close to the edge of this. So I need to step this in here. Do I? Yeah, no, that's close enough for me. Right, so yeah, no, I just need to make a cap section that comes off the end of that. Right, easy enough. Easy enough. That stays hollow. Right, start sketch. The wing's about to get a little bit longer. Project geometry. Grab the face. Finish sketch. Extrude. This bit and this bit. Oh, and this bit. Just 1 millimeter, please. Thank you. Fillet 1 millimeter. on that inside line. Not this one, the inside one there. Cool. And we'll add one of 2 millimeters. Not yet. Apply. First I need to make the little step. Start sketch on here. Project. It's got a wireframe mode so we can see what we're doing. Wireframe with hidden edges. And let's go find an image of the original wing. Small radius to another radius and then another radius. Cool. So, where does that extend? From here, we'll just step it out. Okay, and then I want to make you parallel to that straight edge. Draw a circle. Stick the circle on the end of the line. Make it a tangent. Grab a curve. Grab another curve. Yeah, we'll go to that one. Make it tangent. I said make it tangent to that one. Make you tangent to that. Make you tangent to that. Click OK. And now we can set minute little things like this and that. But that looks pretty close. Let's look at when he added it on. It is this image. There's a bit more of like an upsweep to it. I think maybe we should use a curve instead of a line. We'll drag you up a bit. Grab a curve. Stick them on there. That automatically tangents to that. Tangent to that. Click OK. Right. Let's get a dimension from you to you. I'm just going to put a random number in for now because we haven't set the diameter of this curve. Let's drag you back out. There we go. Now I can set you to like 7. Ooh. Behave. 6. Come on, why doing the weird shit? Why are you doing the weird shit? There we go. A bit less on that. Let's stick you back on there to that apex. Bring it back just a touch. Winner, winner, chicken dinner. Let's make this a bit bigger. Let's go to a 10 on that. Drag your ass back out again. Because we made it bigger. I'm just going to make this a function of this plus... plus close open bracket D195 divided by 3 close bracket. So it is a function of the width, the diameter of this the curve plus a third is the height that the no, that needs to be divided by 2 plus 1/3. And it does funky stuff. That's alright, we can fix funky stuff. Like so. That looks better. Let me just adjust this down. Hey. Here we go. How you going, Jacob? Sorry, I just missed you on the chat there. How you going, Yukon? Yes, how's it going, everyone? Sorry, got carried away there. Yes, I am modeling a RC model of a bush plane that I'm going to 3D print and resin print and build and fly. Like, it's a 1/5 scale. As always, quality stream. Thanks, man. I appreciate it. Right, so that looks pretty close. Let's trim that up and let's extrude it. Split. Select. Sketch constraint, that makes it invisible to everything else. Finish sketch. Extrude. Let's just come out by 5. Click OK. Was 5 enough? Alright, let's look at our reference material. Always be looking at the reference material. By the way, those drag coefficients and such helped me tune my rocket and we nailed the gimbal test. Oh, that's fucking awesome, dude. That is fucking awesome. I'm so glad to hear it. Right, where be the thing that I wanted to look at? This one. Yeah, so it's just a little step that I need. And we've already got that 10mm hole there lined up. So that carbon fiber tube, the 10mm tube, I'm going to hopefully find a 10mm carbon fiber tube to run all the way down the leading edge. That's going to stick out there a little bit for this grab hole. And I'm going to make a little nubbin that prints into it. That's going to fit into it. So now that we've got that, I'm actually going to boost this up just a little bit, that extrude. 5's not quite enough. We'll go to 7. Just because I want to put a small fillet in this edge here. And then I want to start a sketch on there. Project the geometry. Offset the geometry by 1mm. That's the skin thickness of the wing. Go back by 6. Whee, rip headphone users. Sorry, guys. Good thing I've got that. Do I have that turned down? No, I don't. You guys got that full blast. Holy shit. Let me find the volume mixer. Find inventor. System sounds 0. Thank you. Right, let's not deafen the audience. Oh shit. Yeah, Inventor does that from time to time when it's like, no, you're not allowed to do that. I won't let you. That is bad. And you're just like, oh, come on, Inventor. Really? Actually, I need to go 7 on that one. Why am I not seeing all the way through yet? That didn't make much sense. How big did I make this step out? Oh, I stepped it out by 7. Right, that's right, that's right. Cancel. This fillet, I need to not have that there yet. Right, because it's not needed. Now it's needed. Alright, so we wanted this one to be 1. Screw it, let's make it 2. Because it just adds a bit of strength. Doesn't cost that much weight. That one we can get away with 2. We can? Cool. Click to add. Let's make this one a 1. I want to smack a little bit of a fillet in there. It's not entirely necessary. It's not necessary at all. He's got a hard edge in there. No, that kind of looks like a bit of a fillet. He must have done a bit of body work. I would have. He's riveted this thing. He's made it a fixed modification to the wing. I would have placed a fillet there just to make things handy and dandy. I mean, he's rounded that little edge there just a little bit. I'm going to do that anyways as well because it just prints better. Just like so. Now it's a bit like you don't normally do this, putting a larger fillet on the inside of a hollow shape, whereas on the outside you have a smaller fillet. It creates a weird cross section if you look at a cross section of the material. But I only need a little bit of fillet on the outside, and the larger fillet on the inside is more for the strength and aesthetics, so that's why that's like that. I can probably extrude this further through. Click OK. Yeah, that would look cool. It would add a bit of strength. Oh, and while I'm at it, I need to cut that hole. So, when we were doing this one, let's jump back in here. Project geometry, give me that line. Yep, finish sketch. Open the extrude. Profile. Omit. Oh, this is the wrong profile. This one. This one. Profile. Omit the hole. Ta-da! Now we have a hole. Might as well just extend that as well. Project. New sketch. Extrude. Sweet. Right, that makes that corner nice and stiff and strong. It eats its vegetables. And it's a pity that this one wasn't on the same thing, but anyways. Sketch, project. Sketch, extrude. Distance to next. Other way, please. Alright, I'm just gonna have to tell you where to go then. Right. Got a start of a box section here. I think we might extrude this along here. Yeah, let's do that. That's a great idea. Let's do that. Alright, project geometry. This face, this face. We also need this face. This is going to be a bit of a tricky cell. It's going to be a bit tricky to get this one to work. Basically trying to copy what I've got. It's not going to work. No, I just did it in my head all the way through to completion and it said no. So let us do that again. Delete the sketch. It's the easiest way to get rid of the geometry without leaving any shit behind is just start again. Same face again, but this time I'm only going to use this one. And I'm going to select the stuff in the backside. Backside. Look at that tiny little thing, almost missed it. So I can't select like this area inside of the hole to select all of the hole geometry. But no, I have to come in and select all the individual sections of the line that make up the whole cross section. That one, that one. Let us select this outside rim so we know where our boundaries are. Now, see this one here where like it's not going to work, and even this one I don't think it would work. No, that's not going to work either. So let's backspace, backspace. Deselect that one entirely. Can't use that one. That one, right. So let's re-select this so we can see what we're doing. Let's go to wireframe mode. Alright, so can't use that one, can't use that one, can't use that, can't use that. We can use this one. Yes. So what else has everybody been up to? Let's get some conversation going in chat. Get me multitasking, eh? Unless you guys just love sitting here listening to me ramble about shit. Speaking of rambling about shit, I was rambling to myself earlier. I'm on the RC groups forum, looking at the other like 3D printed aircraft that people have done, and I come across this Avro Vulcan, and I'm just like, okay, the guys had a go at it. It was like, good work. Like, you know, it's a very, 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 very basic. I'm not knocking the guy's work, right? Not everybody can do shit like I do. It's good effort, right? But the thing that got me ticked off, and let me show you guys. Where is it? Let me find this link. Hold up a second. I've got to show you guys this. Like, and again, look, I'm not saying anything. I'm not trying to be mean to the guy or anything like that. It's just something that he's done that ticks me off. So I'll show you his work and what he's done. He's accomplished. He's like, I haven't built a full RC aircraft yet, right? So he's already achieved something I haven't. Like, props to him, right? This is the aircraft. Okay? I don't know about you guys, but that's not how the wing looks on a Vulcan. All he's done is very simple, basic lofts. There's no curved edge to this, right? It's a very basic 3D printed model, okay? Not a problem, right? All well and good. That's what he's capable of doing. He's done a great, fantastic job. Except the wings don't align properly because of the way that he's done it. And they think it's something in the, what is it? It's an error. They're trying to track down with... I can tell you where the error is, mate. It's the way that you've lofted these wings like this. It's not going to work. Each one of these wings has a different aerodynamic profile, and then because they're not blended together, you're getting differentiated areas of pressure above and below the wing, along the wing surface, and it's just going to create all kinds of turbulence, right? That's not the thing that pisses me off. The thing that pisses me off... Give it a minute, this website takes a long time. Right. This is what it's supposed to look like, right? That nice, clean, curved line. He's charging $15 for this model. That's what ticked me off. Like, all well and good what he's achieved and done, but to then go and try and sell that model for $15? Not cool, dude. Not cool. Like, I don't get it. This is the actual plane, or another model of the plane, and then this is his one, and you can see, like, some of the ways that he's designed stuff. Ugh. No, you don't sell this. You don't charge money for people like that. You offer that for free, maybe, and you go build another one and make it better. That's what you do. You go and go do better. It's what I do all the time. Every time I make something, I have to make it better. Make it better. Make it better. Anyways, rant over. What are we gonna do here? Right. Let's get some circles. Let's get some circles going. First, let's go to sketch constraint, offset. Let's come in by, what did we do for these? Well, that one's a whole fucking millimeter, like 2 millimeters away. And all of these are only okay. Okay. That's strange. That's a really strange number that they're spaced away from the walls there. It's supposed to be a mil. Anyways. And let's make a big circle in here. That'll be a nice load of weight not to have to deal with. Let's make it not a sketch constraint. Let's turn that off. Tangents, thank you. That's the one I was looking for. Tangent there, tangent there. This is my favorite tool when you're using curves. This is the tangent tool. Click okie dokie. Right. Yeah, I'm happy with that. Happy with that. Right, now I've just realized something. Because this bar that I have running down the wing doesn't actually go into the fuselage. The only one going into the fuselage is this big 10mm one. I might have to include another one somewhere, but I don't want to interfere where the servos and shit go at the back here. So it might just be a little thing in the back here that I'll put a 3mm or a 5mm spar in. Because that's a 22mm tube that's going there. And if I glue that tube to these frames, this frame is solid. That's a 22mm carbon tube. Like, I don't think you guys realize a 22mm carbon tube is hella crazy strong. Yeah. Right, offset 0.5. 0.5? Nah, we'll do a mil. Let's do another mil. Where'd that other one go? You. Thank you. Select you. Make you a sketch constraint. Let's find another circle. Let's go back to the right hand view. Thank you. Let's chuck a circle in here. And then we'll do sketch constraint, offset, dimension, select you. Right, then we select that, not using caps locks. Control CV, drag that over there, select it all again, Control CV. Yep, that'll be enough. Right, tangent you to you. to you, you to you. Lovely. This guy, that guy, this guy, that guy, and this guy, and that guy, this guy. Lovely. And then we'll have just space for one more in here. Yeah, man, I hope so. Next level CAD, yeah. Have you seen this the leading edge spar yet? Have I shown you that? So I've just been working on the wing section for now. Let's open this up. This is the leading edge slat. I'm going to come in and save some more weight. I'm going to change all of these fucking ribs. I've just noticed that as well. I can change those as well. Use a different method. That's way too much weight. Every ounce counts. Every ounce counts. That is the mantra. That's what Mike Patey used to say on his build logs. That's what I need to be saying. Every ounce counts. We'll come back and we'll change that later. Let's finish this off. Let's get a tangent from there to there. And how are we going to space this? I know. Let's just do it super easy. You draw a line from here to here. And then you draw a line from there to there. You click OK. And then you take this button, you click on that line, and you click on that line, and then it makes it go in the middle. Next level shit, I know, right? Okay. So that's the weight saving done over there. And are we going to cap this back section off? I think we should. No, we shouldn't, because it's just weight. We don't need it. This can just be a slot section that tabs into the rest of the wing, to the fuselage on the aircraft. Let's click finish. Okay. Let's go extrude. We want to... Hello. Why can't I... Oh, I click start sketch instead of extrude. Right, there we go. Hey. No. Okay, so you let me select the circle inside, but you won't let me... come on. I hate it when an inventor does shit like this. Come on. Behave. It's not letting me go right. I want to extrude just this bit. That's not cool, bro. That's not cool. Okay, you know what? If you want to play like that, I can play like that. End of part, past the sketch. Start extrude, start sketch there. Reselect that perimeter geometry, yep. Finish sketch. Extrude the inside of the perimeter geometry, but do it the other way, so it sticks in. We only want to go 1 mil. Go 1 mil. Click OK. Come back with the sketch. Click extrude. Only select the holes. Has anyone else figured out what I'm doing yet? Hey. Come on, you can do it. There we go. Hey, come on. Why? Are you missing some geometry, some shit somewhere? Like, what the hell? Why is this slot... Oh, it's missing that little section there. You cunty McCuntface. Okay, we'll click OK. Go back into the sketch. Where are you? Where the hell are you? Extrude. Sorry. Project. Not extrude. I've got extrude on the brain. This rate, my brain's gonna be extruding out my ears. Finish sketch. Extrusion. Select the slot. Go the other way. Make it a subtraction. Click OK. In your face, inventor! In your face! Yeah, you're gonna have to get better. Get good. You're gonna get better than me, you're gonna have to get good. I know your tricks. I know how you operate, young man. Young man. Oh, excuse me, what is the size of one of these holes at the back here? 3.2, so I can put a 3mm rod down the back of that. That'll work. I mean, it'll be a bit loose. Center distance. Radius 1.5, diameter. That's a 3mm. Yeah, so I'll stick a 3mm carbon spar down the back of that. Let's go chuck that in there, actually. I don't think I have one that's the right length. I have a 3mm spar that I use in the slat, but that's only the length of the slat. That won't go full length for me here. I say. Work or not, there is no try. Yeah, let's just make a new one. Assembly, update. Create. What we will call this, the alignment spar. Core, wing. Alignment. And spar. C-mill. 3mm. And we put CF at the front here, so I know this is a carbon fiber part. Clicky OK. Clicky start sketch. Make 3mm circle. Finish sketch. Extrude the circle. Let's go. Let's do a full meter. 1000 millimeters. And we want CFRC, not CFRP, because it's a filament carbon fiber. It's not made out of the fiber like the weave. It's made out of the fiber individual strands that are all extruded into a single doodad. Save. Return. And let us constrain you. Out of the way. Out of the way. Out of the way. Lovely. Now let's just slide it all the way in. Oh yeah, look at that. And that'll just stop things from twisting too much. Lovely. Save that. Click OK. Let's come back here. Right, I want to project that all the way. Finish sketch. Extrude that to next. Okie. We shall now go grab our fillet tool. What fillet did I use in here for these? Where are we? This one. 1 millimeter. Right, let's grab you all the way around, please. Yes. One on this side. Yep. Lovely. Whee. Oh, that looks good. Okay. Now, I actually want to make that 2 mil thick. So we have to come back to this extrude, not that extrude. Because that determines the thickness, and we'll go 2 mil on that. This one. Yeah. Sweet. Makes it just a little bit thicker. Love it. I like it, like it, like it, like that. Alright. I've been putting it off long enough. It's time to start working on the flapperoonies. So let's do it. Let's do it. Where's my master form? Master form wing IPT. There we go. Solids. Select the flapperoonie. Now, before I get started on that, I actually want to come in here on the flap/aileron. We want to first do. Well, let me get this right in my head. We first want to do, because it's starting from this side. Yes. And extrude from just inside of this surface all the way to... I think I have one too many of these hinges. I think I do. There's only one in the middle of each flat. And if I count these right, that's the middle one. And there's 3 in the middle. If that's the middle one, there's 3 in the middle. So where did I go wrong? Ah ha 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 ha. I know what happened. It is an easy fix to do. Right, so when we came in and we added those extra spars before, these extra ones, I have this middle one that I made first, right? This middle one. That extrusion includes this bit. So when I was creating those extra spars, I was creating extra hinges. So it's an easy fix. I just have to come in and create a sketch on each one and hit extrude negative, like subtract and subtract each one off. Or I could leave them for some extra, strength. It won't be perfectly scale, but nope, they have to go. It's not scale. So that one needs to go. That one, and it's annoying that it's every. Oh, you know what I could do? Let me measure that face to that face. Click that button. Let me just copy it. Right. And I can start a sketch on one of the ones I want to remove. Project its geometry. Out. Finish sketch. Extrude. Select. Go both ways. Give it a good amount of distance because they're spaced differently on the other side. So we'll say, I don't know, 40 should do the trick. Create that as a subtract. So it will remove everything within that sort of area. Click OK. Right. Then we're gonna go rectangular. We've used so many rectangular functions on this, it's not even funny. Select that extrusion, select the x-axis, paste in that number, swap the direction. Yeah, okay. You're supposed to subtract that. And let's do 1, so it's 2, 3, 4. Okay, it got that one. It missed these. By how much? Because it's not showing it to you. It's invisible. So let's bump it up to like 80. Okay, it got that one. It missed that one. I think it needs to come this direction. So let's only do that direction. Wait, what broke? Ah, right, okay, no, I need, yeah, because it's on that side of it. Cancel. Open it up. Let's do both directions. 80 on that side, 40 on that side. Nope, it's knocked the end one off. I'm playing whack-a-mole here. How much of the... Oh, it wiped out the end completely. Right, wrong direction. Yeah, that only needs to be like 2. And that can be like... Fuck, let's just do 100. Yes! We got it! Lovely. So we have now the correct number of inches. Right, where was I? That's right. Making the flaps, the ailerons, making the ailerons, right. So we need a measurement from here to here. 218.5, knock off the 0.5 so that we have 0.25 clearance on each side. Come back to the master wing form. You can go away now. Thank you, Benjamin. Yeah, go away. No, thank you. Bye. God. What did we say that number was? Shit. Sorry, Benjamin. I lied. I still need you. From here to here. 420. Why is the number different now? Did I measure from here like a doofus? Oh my god. What an idiot. I'm such an idiot. Okay. 429 minus 0.5. Flap slash aileron. We did select the right side. Yeah, that's the aileron. Cool. Aileron. 428.5. Yes, cool. You know what, let's bugger off that 0.5 and just do 29. Let's go full hog. Hey, nah, just 9. Just 9, thank you. Just 9. Sweet. Right. And then I can change this to just be aileron. And then offset from here by 2 mil. Start sketch on there. Project geometry of that. Finish sketch. Extrude. Not yet. Let's cancel that. Let's measure. Measure, because there's an A in there. Measure. To here. 529. And yes, they are different for a reason. we can take that work plane and tell it to go to hell. Because I hate seeing work planes. Save this. Close it. You don't need updating, but you will need updating. Update you. Nothing broke. Fantastic. Wait, why did I close that other thing? I still need you. I still need you! Master form, wing, IPT. This one. Yes, thank you. Let us select solid bodies. Wing 4. Slat. Huh. So just because I used it there, I can't use it again. Okay. Slat. Solid. Actually, no, leave that as solid 2. I can't change these. No. Solid 1. Can't change these. These have to stay there because they are referenced to other things. If I change it, it will break stuff. What am I doing? I'm being an idiot. Solid. Is there a space on there? There's not. It's just solid 1. No space. Alright, leave it alone. Don't fuck with it. Save. Alright, okay. Select. Oh, actually, this Doosan needs to be a new Doosan. Okay, cool. Solid 5. Solid 4. What is solid 4? Nothing, apparently. Oh, that's right. Solid 4 is the wind tunnel. Right, select solid 3. Manage. Make part. Do not place in assembly. Actually, place it in assembly. Let's place it in. Create new target assembly, select no to select an existing target assembly. Yeah, that's what I want to do. No, not in the reference file. Why would you even look in there? There's just photos in there. Oh my god. Wing main assembly. Select that one. Click open. Right. And this will be a rune form right. I don't know if I'll be chopping it up into multiple pieces to 3D print yet, so I'll just use a form, and then I'll use the same thing that I'm doing now, which is to take a thing and make it a thing. Solid bodies, solid 3, fantastic, name's good. Automatically place it in an assembly file. We happy with that name? Did I spell aileron right? Is it AE or AI? I'm pretty sure it's AE. Aileron. It's French. You know, the French were the first people to build airplanes, mass produce them, really. I know the Wright brothers were the first ones to fly, but all the terminology that we use, like fuselage, aileron, elevator, they're all French names. It's AI. Can you believe it? I spelt it wrong. Let's spell it right, otherwise the internet peoples will laugh at me. Cool. Apply. Sweet. Oh, should have just hit OK. Didn't want to apply. Right, let's go in here and change this. Okay. Don't want people laughing at me now. We don't want that. The grammar Nazis will get me. Sweet. Why has this changed again? What the hell's going on here? Where are my material? Why is this? What is this? I don't even... What the hell? Come on. Material overrides. Select all. Remove. It's supposed to be smooth red. All of it. Because it's a red wing. Save. Okay. Right, so we have the first flappy flap thing sitting there ready to go. But it's not quite in the right place. We do not want it nailed to everything. Excuse me, what? Grounded. Right, now before we move it, I just want to slide it along out of the way over there without changing its angle or anything. We want to constrain that surface to that surface. Apply. Which should automatically space it for that surface there. Looks like they have. Well, check that we got our numbers right. It's in the right place. Yes, it is. Fantastic. Let's drag it out a little bit. Go to the bottom. So we can see what the hell we're doing. Slide it up a bit. Now, just for while it's sitting here, I'm going to constrain that circular area to that circular area. Click OK and apply, because that lines it up so that we can set the control horns and the hinges correctly without it going all freaky deaky. Lovely. And while it's sat there now we nail it to it. Grounded. Thank you. Awesome. Right, let's get into it. Open, open, open. First thing we're doing, making this thing hollow. Click OK. Now, if I measure this is way too big for my printer, so at minimum, I'm cutting this cut in half. At minimum. Let me do the math. If I cut it in half, that's 205.5, which means I'll be able to lay two of them down in the print bed. I won't have to stand anything up. Cool. And that reduces print times. If everything's laying horizontally like this, it only prints that time. Like printers, the resin 3D printers work by height time constraints. Like, it doesn't matter if you're printing a full solid block or a tiny little thing. Determines the time of print by the height of the object. So the shorter things I can make, the better. Or the lower I can lay them out in the print bed, the better. So, cool. We are going to cut this in half. Which kind of makes sense. We have made it hollow. Let's look at some reference material before we get any further in. Make sure we're not screwing anything up. Now this is the aileron, which means it is the one on the outside, the one that we can see in one of the photos. And it is covered by this platey plate thing. Now he made changes. He increased his aileron size. You look at that one there before he made the modifications, and then you look at this one after he made the modifications. They've cut that plate and they've extended the aileron a little bit. This is the step here. And I've modeled that step into the assembly as well. It's this step here. Whoa. That way. There we go. So I will need to make a cutout here as well. Which means I need to go back to that shell function and go, sorry, not yet. Now, we're working on the right side of the wing, the step's on this side, so we come over here, we select that base, and we put a sketch film. And I'm pretty sure if we look at, did we close that reference? No, we didn't. That just looks like a 30-degree cut. 30-degree cut from the straight edge of the bottom of the wing. Now I've made mine completely straight. There is no change whatsoever here. And for reasons which I'll go into right now. Because we've got all of these stiffeners that go all the way down. So what I'm going to do is I'm going to leave it as it is, and I'm going to create a subtraction extrude function that will cut out a little step in it, and then I will repeat it all the way down. Anyways, let's get this step in. Let's come to wing form. What is this? Let's save this and close it. Right, we will use this as our measurements. The step needs to be a little bit over 10 millimeters. I'm just designing everything absolutely flush. I will sand stuff down when I print to get my fits. So everything I'm making with zero tolerance, except for certain things that I will have to design the tolerance in, like when I start working on the variable pitch pot, when I'm doing like the planetary gears and all that complicated stuff. So 10 mil step, let's make it. Project geometry, this one. Come in here, grab a line, stick a line on here, stick it to there. Now, what do you know? But I bet you that that is perpendicular. And if I measure that, that was close. It was 70 something. 78. So let's call it 80. That's 10 degrees off. So yeah, not perpendicular. Delete. Grab the point. What I'm chasing is a 30-degree angle here. So we need 60. That's too much. I'd say 75. So it's 25-degree angle. No, I was right the first time. Closer to 30. Let's just do 65, just for shits and giggles. So it's not quite 30. That looks better, yeah. That's on the money. Yeah. Sweet. And then we are going to measure off that. Nope. We are going to measure off this back one, because this will be a constant factor. Let's just set it for 65 for now. We'll come in here and we want to measure from here to here. 78.326. Let us call it 79 and we should be good. 79. Oh, hello. Interesting. No, we need to be less than 78, so let's go 75. Let's give it some clearance. Yeah, that looks better. Where's my picture gone? It's still a fair bit further back. Like, if you look at where the front leading edge of it is. I think he made his just way pointier than mine. Right, so before we go any further, let me finish the sketch, leave that alone. Let us come back to master form, this one. I'm not happy with something. Ailerons, sketch. I am not happy with something at all. Delete. did I do here? This is all garbage. Reference. Bring back my reference. Yeah, I had that curve in there. I should have kept it. Let's do this properly, okay? That was not properly. Concave. I should have followed my reference. It looked a bit funny to me, so I didn't. And I should have. No, where is... It's not this one, is it? No, it wasn't. Whoa! Alright, let me just... let me sort some things out. You. 16. Nope. 15.5. Lovely. Don't move. Right. Grab you. That's better. Sweet. No. Alright, let me set some dimensions on some stuff because it's just moving around too much. 6.5. Yes. Okay, I'm happy with that now. Don't move. Stay where you are. It's the police. Just trying to flatten this bottom one out just a hair. There we go. Spot on. Happy days. Hey, what are you doing? No, 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 no. Stop it. Cool. Right, you stay right there. Nail it. Thank you. And then grab... No, don't nail that one. Just move it. Thank you, please. Yes. Bit more. Bit more. Alright, I'll call that close enough. Cool. That looks heaps better. Heaps better. Save. Let us hide that reference geometry. Awesome. Right, now we come back into here and we can update this. Cool. This doesn't need updating. This does. Update that. Please don't break anything. Wing R assembly. What? But I just checked it. There's nothing wrong with it. It didn't change. You know what it is? It's this here. That curve there. Which, if I remember correctly, is all the way up in the beginning of the thing. In the master form. Nope. Should be somewhere up here. Full of shell function even. Yeah, this one. Yeah, we'll leave it as is. It's not referenced to anything, that's why it doesn't change. It's a good thing, I suppose. Alright, leave it as is. Save. Lovely. Alright, back to this. Aileron! Aileron! Nope, not that one. Close up. This one. Lovely. The sketch updated. Kind of. Just need to replace a couple. I hate it when you got really flat curves in an image, in a sketch. It puts the center of the curve way off in the distance, and then when you double click, mouse click to put the geometry in the viewport, it also puts in those way off in the fucking nowhere yeeted center points. And then you have to spend an eternity zooming in to wherever your geometry is. Oh my god. It's so bad. Alright, hello line. Right, you're not connected to Jack Diddley anymore. Right, I'm going to attach you to... And we're going to get rid of that dimension now as well. This song is trippy. What did we say? 75? 75. Oh, look at that, it worked out perfectly. Finish sketch. Extrude. Come on, that one. Yeah, cool. All the way. 10 mils. Sweet. How lovely is that? Right, let's shell the thing. Shell worked. Lovely. Let us fillet that 0.5, please. Just so we don't have a sharp edge on the inside there that screws with 3D printing. Click OK. Now let's go into the middle of it. Midpoint. From here to here. Start sketch. Visibility, bugger off. Project. That doodad. From there to I want to say somewhere like here. Let's actually use that function. The one that's highlighted there where it says 67.6605. Yeah, let's do that one. And let's go 68. And then let's bring this in. 490. And shouldn't have done this yet. Okay, let's finish the sketch. We've made multiple shell functions. Delete all features below end of part. Let's slide this sketch. Oh, it won't let me. Slide the sketch before the shell. Move before the end of part. This is probably going to break now because we're going to be changing stuff. Oh, excuse me. Whenever I drink coffee, it gives me not indigestion, but feels like I've got a burp all the time. There's nothing a burp. Sort of like hiccups, but not hiccups. It's like if burping were hiccups. Top of the wing, please. Image of the top of the wing. Top of the wing. Top of the wing. Top of the morning. Anywhere? Anyone? Please? I have no images? Other than this? Yeah, they're about the same. Okay. Let's go to that sketch. Switch to wireframe. Let's create another one. Nope, this one. Yep. We will do the same thing again. We'll come to the end of this semicircle. To this time, we are going to go to the end of this curve. And this one we will make 350. Okay. Happy, 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 happy. Extrude. No, don't. I know you can do it. Come on, come on. Yes. Same again. Come on. Yes. There we go. Both directions. We're gonna go. We want a 1 mil gap. So we will do 9. Make it a subtraction. Whee. So the sketch points just screw up the middle mouse click. That looks about the right size. Click OK. Let us go to technical illustration. I want to create a fillet. Very small fillet. Smallest I can from my printer. No, we'll go double the smallest. So the smallest size I can make with the printer is 0.0. It's 5 micron, which is a 0.05 of a millimeter, which is 0.05 of a millimeter. So double that is 0.0. It's 0.1. So, and we want. Let's just go 0.2 and see what it looks like. Too small. Actually, round about the right size. Let's grab the insides if we can. Nope, we can't. We'll have to do as a separate function. Click OK. Fillet. Can we do the insides? No, it won't let us. It's being a poopy butthole. 0.1. It'll do 0.1, will it? No, it won't. Alright, just the outsides then. Ooh, we've got to do the underside. Maybe, okay, maybe if we do the inside curve first. Got a 0.2. Yes, thank you. And then we bring the outside curve back. And then it does the outside. Happy days. No complaints. Awesome. Right. You're probably thinking, what the hell is he doing? Well, I shall show you. We're going to bring back our favorite tool, Mr. Rectangular. We're going to select the extrusion of the two fillets. Select direction. As always, the x-axis, the favorite x-axis. We're going to go both directions. And we are going to go... what was the size of this thing again? 400 something? 400? Let's just do 49, because we know it's a 10mm feature. 49. Doesn't matter if it overruns, so long as we have a 1mm gap between each one. It's a 9mm feature. Ooh, we're gonna have an issue on the edge there. So let us reduce this to 9.5. No way we can get away with just 9. It's gonna overlap. Yeah, see there, it's how it overlaps. 0.5 should do the trick. It'll give us this bit of a flat edge. And it won't come all the way to the very, very edge. It will. Spacing, distance. We're dead set in the middle, so I'm gonna just click measure. Here to here. And it was 429. Distance that it's gonna do it over. We do not want to put 49 of them in there, we want to put 42. Lovely. And on the other side, lovely. Awesome. Like hell you did. I just saw you do it. You lying, conniving bastard. Let's just do 40 because it's got... No, 39. 39. No, 40. There's one on the end. So strange. Oh, you know what it is? It's the fillet. It's doing a screwy screw up here. Along this corner edge there. Right, so if we do 42.9 as our spacing, set to spacing. No. 4.29 times by 2. Not overlapping too much. No, so we do need to go like straight 9. 42. $43. 10. Yeah, no. Right, do that. Whether it does it or not, I'm going to save after this. I need to save it. It worked. Save. Oh yeah. Let's go to perspective mode. Let's have a look at that. Sweet.
First of all, what went through my mind is how stupid am I?
What does it look like on the assembly? Oh, yeah. Yeah! That's what I'm talking about. That is what I am talking about.
Unbelievably painful.
Probably should put a fillet on that edge. Yep, we'll use that fillet. Or no, we'll use that fillet maybe. Or we'll make a new fillet. Clean up this inside it over here. This one, click to add. One. Wait. To add 2. Need a fair bit of strength there. Select that one, select that outside edge. This one here, and this one here. That's kind of weird that it doesn't. We don't need to do the top one. Select that 0.5 for the top. Doesn't want to do it. Yeah, it doesn't want to do it. It'll do the bottom though. Oh my god. Would you like just stay like in the area, the just general area where I'm working, please, when I'm rotating? That would be lovely. Thank you. Yes. Click OK. Now, do I have a hard edge all the way on the inside of this one? I think I do. I do indeed. That is no good. Let us create a fillet. 0.5 will be enough because it's on the inside. Well, this will strengthen the hell out of it. Now let's grab it from the other side. This one, and this one, and this one, and the little itty bitty one inside of here. Lovely. And that one. I just added a heap of weight, but it's worth it. It's strength. It's strength, not weight. But every ounce counts. Every ounce counts. Right, back to the aileron. Speaking of every ounce counts, we need to make this motherfucker hollow. Will it break the shell? Will it break the shell? Will it break the shell? I think it will. I might have to do it manually. Just look at some coffee. There's coffee in me. It's no good not in me. Here's a strange question for you. Do you put salt in your coffee? Yeah, you heard me right. Do you put salt in your coffee? I don't put sugar in my coffee. I put a little bit of salt. It actually makes coffee taste really good. You should try it. Just a teeny bit, like a quarter of a teaspoon. Right, this shell function is going to break stuff. I know it. Did I save? Nah, it shouldn't break stuff. It should just go, no, I can't do it. It should just say, no, I can't do it. How long have we been streaming for? Coming up on 3 hours. I'm gonna have to tell this to not do that. Please recover, 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 please recover. No! When did I last save? Oh, it recovered! Feature reorder failed. Yes, okay, cool. I accept. I am okay with you not being able to do that. That is entirely understandable. I will not ask you to do it again. That was a close one. Save. Save everything. Let's update here. And then save. Yeah, the music kicked in just in time to tell my software, don't stop. There we go. Oh yeah, it's looking so much better. Still gotta come in and put the rivets on the wing. Fuel cap, fuel vent, other bits and pieces. But I'm gonna make all the access hatches for the servos and stuff, but I haven't decided. I might have to go with bigger servos, looking at the size of these tiny, these not so tiny in real life servos, look tiny in this wing. Let's go wireframe. Look at them. These are. I mean, you can see the name of them there. There's the Turnigy TJY 930s, and they look small. I mean, it's as big as like the two like the two phalange bones in my index finger across. You know, like they're decent sized servos. They came out of a helicopter. They were pushing the helicopter blades around, so I don't know. Maybe they're strong enough? I'll have to go look up this data sheet for them and check. Do some math, but let's just get on with building stuff. Here we go. Technical illustration, save. Yes to all. Why would I not save anything when I hit save? Ailerons. Right, let's make it hollow. Start sketch. Let's go to that center work plane again. Let us project. Let's just do this side first. Wait. That one? Yep, cool. Offset. Ooh, you don't want to offset in? It probably is, but I just can't see it. Yeah. Wireframe. There it is, there it is, there it is. 0.5 fillet. On here, please. Thank you. Always say please and thank you to your software. It crashes less. It really appreciates the thought and effort of being polite and kind. It really does. I'm not even joking. Now, let's just double check that these cutty outy bitty bit things aren't going to intersect. Oh, it's getting mighty thin here. It's getting mighty thin. What I might have to do yeah, no, that'll do. Yeah, let's just redo. Right. I will have to project that line and this line and then offset them by 1. Sweet. And then I can trim. Can I trim any room? Trim that one. Trim that one. Which is made up of multiple curves. That's fine. What? Okay. Looks like we're not using this. Why? Fill it. That line and that line. Click OK. Right, that'll give me nice. It'll be a bit thicker in places where those chines are, but are they chines? Do they count as chines? No, they're not. They're vortex generators. Okay. Now to make it look scale, because if we look at the tailing edge of the wing after we modified it, those ribs only sort of like go to a point and then they stop, and then he's got that more flat section that he put on the wing. So in order to accomplish that look, I will do this. This is very naughty. You should never do this kind of thing. Does that line intersect? It does, because remember I pulled it off of that curve. So I'm gonna say from there it'll look good? Yeah, it'll look good from there. So let's, no, I just want to put, hello, thank you.
Stop.
Okay. Doing a strange thing there, aren't you? Yes, you are. We need to project that. And we need to project which one? This one? Yeah, I think it's this one. This one and this one. That one. Or this one. Oh, it's so hard to see. Let's go to proper wireframe. Makes it a bit easier. Basically, you know what? I will leave it. I'll do it in a separate extrusion. I'll leave it and I'll do it in a separate extrusion. Finish sketch. Extrude. Oh, come on. Don't be like that. Holy crap. Whoa, that's why. Orthographic. Close loop. Yes. Yes. Loop's been successfully closed. Cool. Let's turn that perspective view off. That's going to screw me over. Extrude. You. Let's go the other way. Let's do a subtraction. Let's measure. Got 429 divided by 2 minus 1. Lovely. Sketch. Extrude. The other way. But let's, instead of -1, we minus 11 to make space for that cutout. Finish sketch. Start sketch. We want to grab that inside face. Yes. Just doing all that funky kind of stuff. We want to project this face. We want to offset this face by 1. And we want to project this one and this one. And then trim all of this stuff. We don't need that. We'll make sure that that's connected. We'll do a thingy do dad. Trim here. Close loop. Loop has been successfully closed. Finish. Extrude. 10. Other direction. Yes. Holification successful. Haha, Bleach reference. I love my anime. We now have a hollow aileron. How awesome is that? Whee! Next, we want to make control horns. Or, well, they're technically hinges because they connect to the hinge of it's the hinge point for the flaps and ailerons. And they have internal control horns. So, we'll do that. Come in here, let's grab some measurements. So that face there is good. And that face there is good. We just need one in the middle. The middle of that and that. Let's double check. That and that. 210 plus that and that. Not 210. U to U. Yeah, 210. Oh, excuse me. Wow. So, I think we're gonna have to save this one, close it, open up the wing assembly, and edit it here. Let's do the first one over here. Wireframe. That. Slot. Project. Where do we want to connect it to? There, to there, to there, to there. Let's grab that one. There. Sweet. Grab the line. Get rid of the parallel constraint. Make this 4, because I can remember the other one was 8. Make this 6, because I can remember the other one was 12. So it gives us that nice bit of thick, like, angularity to it. And that's it. That's all we need. So we shall extrude this the other way. 1, make it a thing, not a thing. Now I've only made it 1 mil thick, but I want it 2 mil thick, but I do not want to extrude onto the inside where I don't need the material. Actually, we probably should. Probably should. Yeah, let's go 2. Let's give it that extra bit of because that's where I want to run a spar through there. Run a spar through there, and I'll have another one somewhere on the inside. Cool. Awesome. Totally awesome. Shout out to Lumpy Space Princess. I watched Adventure Time recently, like marathon the whole lot. I didn't know they brought out like the whole like. I missed seasons 8 through 10, and now there's a new show, which is Adventure Time Distant Lands. That was actually pretty cool. If I watched the first 2 episodes of that, I wonder if there's going to be more. Direction, as always, the x-axis. What did we say the distance was? We're going off spacing. So 480. All the way. No? Can't be 480. What the hell? I'm confused. Was it 480? No, it's like 420. 429. 429? That puts it there. We don't want it there. So that makes it 419. Puts it there. Is it in the exact right place though? No. 17. That puts it in the right place. Let's go. 3. Let's change to distance. That puts 1 in the middle, but I don't want to put that one in the middle. Not like that. So we will switch back to spacing, switch that to 2. That puts the one on the end where we want it. Yes. Okay. Right, so we have at least 2 done. Let's do the middle one. That work plane is the center from the very outside to the very outside. We don't want that one, so we have to make a new one. I hate work planes, I really do, because they just don't go away when you're done with them. Grab that one. Grab that one. Put the work plane there, right click. New sketch. Project geometry. No. Yes. And on the inside, please, we will grab that one. Thank you. Lovely. Cool. Right click visibility. Take that work plane out of my sight. Finish sketch. Extrude. Here and here. Go bi-directional, and we want to go with, I want to say 6. Yes, I do want to say 6, and 6 I will say. Cool. Click OK. Come back here. Right click the sketch. Visibility. Bring it back. Extrude. Let's do it again. Bi-directional. This time we're going to say 2. And we're going to make it a opposite function. Click OK. Sketch no longer visible. We can close that up. Collapse it. Sweet. Awesome. Next up, there is this quirky little thing. Now the ones on the end, it's not too much of a problem, but this one in the middle, I may have to actually, let me come open in this extrusion again, and let me actually just subtract, hey, no, go away, that middle profile. So we keep that solid in the middle there, and because there's a good reason for it. Before we go further, let us grab the fillet. Let's go all the way to 2. I want to grab this one. Yes. This one. And this one, please. Yes. quirky little function with this one here. Where's my assembly fucked off to? Oh, I'm in my assembly. That's why. Realistic. When this flap, this aileron, comes up, it needs a cutout for this one to go in there. Also, that cutout will include where the linkage is for the control horn. So let us go up. Let us grab this one. We can delete that one now. We can delete. No, we'll leave that one. But what we will do is we'll create a new one which constrains this surface and this surface. Click OK. And we can unground it. It's been a good boy. It's been well behaved. Oh my god. It's working. Right, so let me show you this thing that I was saying. Okay, so let us grab view half section. Let's slap a half section over here so we can see what's going on. Right, there's going to be a little bit of graphical area because I've created the half section where the start of that surface is, so it's going to be a bit screwy. Just ignore it, it doesn't exist. When the flap comes up, I've made this just perfect actually. It's not intersecting like I thought it would. Is that so? Is that enough, do you think? Do you think that's enough? I think that's enough. You don't really need that much up aileron. It's quite effective, you know? It's got gravity helping it out. That should work nicely. Cool. Flappy, flappy, yay! Cool. How long have we been streaming for now? 2 hours, 24 minutes? That's not right. That can't be right. I started streaming at 3 AM and it's now 5:15. Okay, so that is right. Not bad for 2 hours work. Did some more stuff on the main wing. Created an aileron. Ooh, that's right. I need to check its interaction with that. And I think I've not made it perfect. Because that's supposed to be the upstop. It might be as easy a fix as just changing the position of this a little bit. But that's more than enough up flap. So end section view. Oh, it's so cool. I love it. This carbon fiber tube is way too long on purpose. Get a nice sexy turntable going. Yeah. Alright, That wing looks so silly being all smooth like that. I need to get the rivets in there. Oh, but I think that's enough for now. I'm gonna go take a break. It's over 2 hours work on the stream. And I've got to keep it minimal because I've got to then go and time-lapse and condense all the stuff for the episode 2, and I need to get started on that. So I'm going to do the same thing again with the flap. Also got to come in and make the internal spars, the ribs for the spars in the aileron. The same with the flap when I make the flap. But we're going to leave it there. So, thanks again for watching. If you're watching it after the fact in the replay, then thanks for watching this far. 2 hours of footage to watch through. That's a lot to go through. I've been Chaos, and until next time, probably won't stream tomorrow. Gonna do some video editing. Gotta get episode 2 out. So, no stream tomorrow. Stream after that. So, tomorrow's what? Tuesday? So, stream on Wednesday. Look forward to seeing you all then. See you later.